either be applied to the entire root, or it can be applied to the radicand. Take your choice. All right. I've introduced a concept without explaining it. So let's go back and talk about what we mean when we see something like that. What does that mean? That's what the answer is, but here's what it means. It means, ladies and gentlemen, what number can you use as a factor? Factor means something like what? Multiply. What number can you use as a factor 3 times and end up with 8?
2.
So that's the answer to the question. So since it answers the question, the cube root of 8 is
2.
But again, the question, what number? You use as a factor, that means multiplication, 3 times and get 8. So anytime you have a radical expression, it's basically asking a question. What number can you use as a factor the index number of times and end up with the radicand? That's basically the concept. All right, let's go back to 8 to the 2/3. 8 to the 2/3 we said was the cube root of 8 squared. Now we already figured out what the cube root of 8 is. It's what? 2. Squared is 4. So 8 to the 2/3 turns out to be, in this case, a whole number, 4. Oh, by the way, you can do this with your calculator also, right? Everybody try to do 8 to the 2/3. Now when you do the 2/3 part, you might need to put it in parentheses, like open parentheses, 2 divide 3, close parentheses, then hit your equal. So see if you can get 8 to the 2/3 is 4. Open and close those parentheses with 2/3 in the middle. See if that'll work. Anybody having an issue with that?
Mm-mm.
Get it? Okay? Everybody else okay? All right. Let's look at some of those problems. And again, these guys will not be a lot of challenge to you since you can do them on your calculator. But as soon as we start introducing x's into the expression, all of a sudden I can't use my calculator anymore. But I can still come up with a radical expression. Let's work this guy. 16 to 3/4 in the radical expression is what? What kind of root? What's the index?
The 4th
4th root of?
to 16.
And then to the
3rd power.
Now, ladies and gentlemen, this is probably the way you want to do it. Otherwise, think about this. The other option is that, which means I got to take 16 to the 3rd power, and 16 to the 3rd power is, yeah, right. We know 16 to the 3rd power. So 16 to the 3rd power, big number, then I got to take the 4th root of that. Immediately, I'm in the realm of my calculator helping me, and I'm not in the realm of stuff I'm already familiar with. This is in the realm of stuff I'm already familiar with. The 4th root of 16. What can I multiply by itself 4 times and get 16?
2.
I'm there. All right, so this means 2 to the 3rd, and that means 8. See the advantage of putting the power on the outside? You deal with smaller numbers. guys that like big numbers, go for the second method if you like. You get the same answer. All right. As soon as we introduce the concept of radicals, we introduce the concept of simplifying radicals. Radicals are either simplified or they're not. And there's 4 standard measures for deciding if your radical expression is simplified or not. Just as you would never choose 3/6 as a final expression for an answer, because it simplifies. Likewise, you would never choose certain radical expressions because they beg to be simplified. Now see, I'm a little bit confused because that's my ringtone also. I thought that was my main squeeze giving me a call. Yes, it was. All right. No radicand may contain a factor to a power greater than or equal to the index of the... Hey, that's simple. I mean, that's so obvious, we'll just go on to the next one, right? No, that's a little confusing. No radicand, oh, that's the thing under the radical sign, may contain a factor, that's the thing that's multiplied, to a power greater than or equal to the index of the radical. So, when I have something like this, two questions present themselves. Number one, what the heck is the index? You may know? Yeah. Do you know that the square root is so common that when you write it without an index, when you see a radical expression without an index, there's an understood 2. And once again, if you want to put the 2 in there, that's great. Doesn't bother me at all. Helps you remember what the index is. All right, let's look at this in light of this first standard. Are you saying it's 5 minutes or are you stretching? Okay, I was panicked here. Okay. So, no radicand, that's the 18, right? No radicand may contain a factor to a power greater than or equal to the index of the radical. Well, I don't know. Some of you do, but I don't know if it contains a factor greater than, a number of times greater than or equal to the index. So my very first suggestion to you is factor the thing into its prime factors and see what makes up 18. Some of you know, some of us don't. You know how to do this, right? What's the method called that you use?
Factor.
Have you used the factor tree before?
Yes.
Wonderful method. So I break 18 into 2 parts, such as
2 times 9.
2 times 9. Wait a minute, somebody else said something else. 3 times 6. Which way's right? 2 times 9, right?
Either one.
Either one?
Either one.
That sounds like anarchy. Well, let's just go with both of them and see what we get. Now, you remember how this works, don't you? As soon as I get a prime number, what do we mean by prime?
It can't be reducing them.
That's right. Divisible only by 1 in itself. The only things that will go into 2 are 1 and 2. The only thing that will go into 3, 1 and 3. They're prime. Okay? So as soon as I get a prime number, stop until you have all primes. Got all primes. This method, there's a prime. Go until I get all primes. What do I get?
Same
The
thing.
same factorization. Absolutely. So 18 is 2 times 3 times 3. Or if you do it this way, it's 2 times 3 times 3. Slightly different. Actually, there is a something called the fundamental property of arithmetic. Sounds kind of important. Fundamental property of arithmetic says you take any number into its primes anyway, you're only going to get one factorization. There is a unique factorization into primes for every well number. Just one. So no matter which route you take, you're going to end up with 2 times 3 times 3 for 18. So you use the factor tree, or in this case, since it's just so small, it's a factor bush. You use a factor bush, and you get a prime factorization. Okay. Oh, by the way, if a number isn't prime, like 2, what do we call it? Non-prime. Good guess. It's not prime. What is it? Who's got it? Who said it? Composite. It's composite. Great multiple choice questions. It's composite, ladies and gentlemen. If you've had your geology, you've studied a composite rocks. Rocks that are blended, put together by pressure, temperature. Same idea. Composite rock has multiple parts. Composite number has multiple factors. Okay. All right. We've got this thing in its prime factors. So the square root of 18 is the same as the square root of 2 times 3 times 3. Now here's the question. Does a factor appear the index number of times or more? What is the index? 2. So does a factor appear 2 times or more?
Yes.
Yeah. That 3 appears 2 times, doesn't it? Now watch. The index tells you how many times you're looking for a factor to show up. The index is 2. I'm looking for something to show up 2 times. Got it. Got 2 3s. And here's the rule of thumb. If a factor shows up the index number of times underneath the radical, it's the same as showing up 1 time outside the radical. So 2 times underneath the radical is as good as 1 time outside the radical. What's left under the radical?
2.
Just a 2. Okay. So the 2 times under the radical is as good as 1 time outside the radical. You can put the square root there also. But why is it that works? Check this out. Square root of 3 times 3. Let's just look at that concept right there. Square, that's the 3 times 3, right? Another way to write 3 times 3 is 3 squared. Can you take a radical expression like this and rewrite it as something to a fractional power? Remember how we did that earlier? We went one direction. Let's try it the other direction. We said 16 to the 3/4 equals the 4th root of 16 cubed, right? Well, can you start off with the 4th root of 16 cubed and re-express that as something to a fractional power? Okay, so there's the base. You got a fraction. Hey, what goes in the bottom part of the fraction?
4.
That's right, the index. What goes in the top?
3.
So let's do that with this guy right here. This is the square root of 3 to the 2nd, which means in fractional exponent form, this is 3 to a fraction. What goes in the bottom?
2.
On the top?
2.
Just 3 to the 1, which is?
3.
Absolutely. So here's my shortcut. If the exponent and the index are identical, they in essence cancel each other out. And they literally cancel each other out. Re-express it if you like, at least in your head, as a fractional exponent. That means anytime the exponent inside the radical and the index are the same, I have to know what the number is. What's the 7th root of x to the 2nd? It's just that. They, in essence, cancel each other out. Let's look at another example of number 1 here. Let's do something besides a square root. How about a cube root? Here. Oh, by the way, this index says I'm looking for a factor to show up how many times before I simplify?
3.
The index tells you how many times you're looking for something to show up. All right? So you can do this in your head. I suggest you don't. You got lots of other stuff going on in your head, like what you're doing after class, or reruns of Everybody Loves Raymond, or just all sorts of stuff. So if you put it on the paper, it's there, all right? 16 breaks down into 2 times 2 times 2 times 2. X to the third breaks down into 3x's. You may think this is overkill. That's your choice. Y to the fourth is 4y. But ladies and gentlemen, this is foolproof if you'll do it this way. I'm looking for stuff that shows up 3 times. That's what's going to simplify. As I look at this guy, what do you know? There's 3 2's. There's 3 x's.
There's 3 y, so it's 2 y.
Now, what comes outside the radical?
2xy.
Absolutely. One of those, one of those, one of those. 3 times underneath the radical. Here is 1 time outside. So I got 2xy on the outside. Still got a cube root. What's left underneath?
2y.
I finished. Is that okay? Not too bad. Let's check out 81A. 26. Hey, when you see 72, what factor do you think of? What times what? 9 times 8, right? Most people think 72 and it's a 9 times 8. So do that. 9 is there's the 9, 3 times 3, times 8, that's 2 times 2 times 2. So it's prime factored down. And I got 3 x's. How many times am I looking for a factor to show up? 2 times. This is a square root. The index, or lack thereof, tells me that I'm looking for something to show up 2 times. All right, got me 2 3's, got me 2 2's, got me 2 x's. What goes on the outside?
6x.
6x. And underneath the radical?
2x.
Let's see at 86A, because this offers another challenge. We'll do this in about 7 more, and then we'll look. 86A. Important question to ask you, ladies and gentlemen. Square root of 2 plus square root of 3. Can I add those two guys together?
Times.
Now, I can combine, when I say combine, I mean add or subtract. I can add or subtract radical expressions if they have the same exact radicand. I got two different radicands, right? That's your square root of 2 plus square root of 3. Got a point? Hey, how about this guy? Can I combine those? How do I combine? What do I get? Yeah. I got one of these square root of 2's. I'm going to add 3 more square root of 2's, so I get 4 of those square root of 2's. All right? So if I do have the same radicand, just combine the coefficients. All right. Which brings us to this guy. Can I combine those two as they are? No. All right? So, go on to the next problem?
No.
What do you suggest? Factor them. Absolutely. You ask yourself the question, I wonder if there's something hiding in here that will simplify. So I find that 27 is 3 threes. I know that 75 is 3/4. That's 3 times 5 times 5. And what do you know? I got 2 of these guys and 2 of those guys that will come out of the radical. Very important question, ladies and gentlemen. What's going to be the new coefficient here?
4 times.
Is it 12?
No.
Absolutely is. I'm going to multiply by that 3. So it's 4 times 3 are 12 square root of 3's minus
5 square roots of 3.
5 square root of 3's. What do I get?
7 square roots of 3.
And I'm finished. So when you see, and you will, a problem like this, where the radicands are different, just know you better simplify because the radicals will probably turn out to be the same when you simplify. All right? See you guys on